Okay, so here is journal 21, and this bell work might seem very off topic, but it's going to correlate well with what we're going to be doing today, or what we have been doing, which is graphing trig functions. So right now we're going to graph some quadratic equations or parabolas, and it's been a while, but parabolas are just those U-shaped curves. And so here I have an equation, and if you remember in Algebra 2, this is what we would call a quadratic equation in vertex form. The reason why we call it this way is because you can grab the vertex easily by figuring out the shifts. So inside this parentheses tells you your horizontal shift. If it's a minus sign, we are going to the right. So this is right 3, and the minus 1 on the outside means that we're going down 1. So the outside of the parentheses tells you your vertical shift. So minus means down, positive means up. So if I were to graph this helps me graph the vertex, but the vertex is just the middle part of the parabola. So I'm going to go, it looks like right 3, and I'm going to go down 1. So that'd be -1 and plot my vertex. And then usually I would just graph my U shape. And in this case, it would be pointing up. I'm not going to give too much detail on why it's pointing up. I just want us to know, like, how are we shifting this graph? So just as a reminder, if the inside tells you if it goes right or left, so inside the parentheses tells you right or left, outside tells you up or down. So like in this problem here, there is a positive 3 on the inside, so this is going to be left 3, and there's a positive 1 on the outside, so that means up 1. And so when I create my vertex or plot my vertex, I need to go left 3, so that's -3, up 1, and plot my vertex and draw my parabola pointing up. All right, so why is this important is because these parentheses go into all types of functions to help figure out their what we call the transformation, different types of shift. Today specifically, we're going to be focusing in on horizontal shifts, so that's why I need you guys to know that. We've already done vertical shift in our trig identity, so now we're just learning how to do horizontal shift. All right, so in trig functions, another way of describing horizontal shift is the phase shift is what we usually call it in trigs. So the phase shift is looking at inside the parentheses, and in this case, in this formula here, it's going to be looking at the H and the sign. So we said a moment ago, a minus sign means right, a positive sign means left, and this H here is just some number, some constant. And so that H value is going to represent the phase shift or the horizontal shift. Now let's just remind each other what the other shifts are. So the A here is always a number in front of the trig value. A is just for amplitude. And so amplitude is that formula that we've been using. It's very short. It's just the absolute value of A. Amplitude is the absolute value of A. So it's always a positive number. The K here is our vertical shift, so positive means up, negative means down, just like those parabolas. And here's the thing, it looks a little bit different today, but B here is our, it helps us find our period. So if you take a look at this formula, it looks like B is a number that has been factored out of the parentheses, and that's something you'll have to take care of. You'll factor out B, and B is always a number next to X, and I'll explain this more in detail when we do an example. But just as a reminder, period is a formula. It's 2 pi over B. B is just a coefficient next to X. And when you factor that out, that's going to change the phase shift. So just as a quick note here, if X doesn't have a coefficient of 1, then factor out the coefficient of B, and I'll show you guys what I mean in the next slide. Okay, so here I have some homework problems that I've pulled from chapter 17.2, and I've pulled a few examples from here. So I'm doing number 15. And so let's start by finding like amplitude and period and midline, because we've been working on that for a while. So amplitude is always a number in front of our trig function. So in this case, a here is 3, but remember amplitude is the absolute value. Let me just write a for amplitude so that way I'm not writing so long. So the absolute value of 3 is just 3. So amplitude is just 3. So that tells me that the highest value on the graph is 3 and the lowest value on the graph is negative 3, because amplitude talks about the height of the curve from the midline. Now, also keep in mind the midline here, there is no vertical shift here, right? Because here's the trig function, and notice there's not a plus or minus sign outside of it. So that tells me there is no vertical shift. If there's no vertical shift, that means that graph is still going to sit on the x-axis, or when y equals 0. Notice how the x-axis here is when y equals 0. So my midline's at y equals 0. My period is something I need to calculate here. So notice that b here is 2. So period would be 2 pi over b, which is 2. And so then the 2's cancel, leaving just the pi. So in this case, period is just pi. Okay, now we're finally at the phase shift. So phase shift, notice how this inside the parentheses here, most people will say the phase shift is 4. Okay, and then put that here. The phase shift is not 4. Okay, it's not right 4 because this is a minus sign. In fact, because this number in front of x is, it's not a 1. So if the coefficient in front of x is not a 1, meaning the x is not by itself, you have to factor out that coefficient. So I have to factor out a 2. So here's what I have to do. So let me put this 2x to the side here. So I'm going to factor out this 2. And if I factor out a 2, that's like dividing, okay? So if I take a 2 out from here, I have to take a 2 from here. So 4 divided by 2 is negative 2. Notice how when I just redistribute this 2 times x gives you 2x, 2 times 2 gives you negative 4. And so now I factored out this 2. This 2 is still my b, which is still would give me the same period. But notice how the phase shift here is actually right 2, not right 4. So this answer for the phase shift is 2 right. Or you can write right 2. It doesn't matter. Make sure you write the number for the phase shift and also the direction. That's really important. So let's try this with the next example here. So here I have my amplitude here is 2. I could do the absolute value and show you guys, but I think you guys are used to that now. So the amplitude here is 2, because that's my A. My period here, notice how my B is 4, which I will also need to factor here in a moment. So 2 pi over 4. If I reduce this, 2 goes into 2 1 time, 2 goes into 4 2 times. So this is going to be pi over 2. So my period is pi over 2. There doesn't seem to be a vertical shift here because there's no plus or minus sign outside the parentheses. So the midline is still at 0. And the phase shift here, let's take a look. So let me bring this down over to the other side. So 4x minus 3. If I factor out a 4, remember that's just dividing by 4. Well, isn't that just, if I'm dividing by 4, isn't that just 3 divided by 4 or 3 over 4? I can write that as a fraction. So in this case here, it looks like my phase shift is 3 over 4 to the right, because that is a minus sign. So this means right, because there's a minus sign, and it looks like my phase shift is a fraction. And notice how if I redistribute like this, 4 times x is 4x, 4 times 3 over 4 is negative 3, okay? So what you're trying to do here is factor out your b if it is not 1. And then figure out what's the direction by looking at the signs, and then what is your new, once you factor it out, what is your new number? Okay, now that we've gotten some practice with figuring out, how to calculate the phase shift, let's actually graph some now. So that's a little bit more challenging. So we're going to try to graph one with a phase shift. Okay, so here I have a sine graph. So let me just remind everyone that sine graphs look like the S shape. So it goes from 0 to 2 pi is one full period. And what that means is a period means the length of one full cycle. So sine makes that S-shaped curve, and the highest point that it's going to get at is +1 on the y-axis, and -1 is going to be the lowest point. And so it starts at the origin, because when sine is 0, when sine is the angle of 0, it's 0 on the unit circle. And then when it gets to about half a pi, it gets to 1, it hits the maximum, and then it comes back down when its sine of pi is 0. Comes back down to here, and then it'll go down lower and then come back up. So sine typically looks like this S-shaped curve, okay? Or this wave, like this hill that goes up and then goes down. And so that is what we're going to try to draw, but there's some phase shift here, so we have to keep that in mind. Now the amplitude here looks like it's just 1, and remember amplitude is just the absolute value of A, and so in this case amplitude is just 1. So that's super helpful because in this case that tells me my graph. Let me just start drawing my graph as I'm going through this. So that tells me my graph here is going to have a height of 1 from the midline. This is my y-axis, my x-axis. So let's go find some other stuff here, the midline here. Notice how there's not a vertical shift, right? So in this case, my midline is going to start at y = 0. So y = 0 is on the x-axis. It's right here. Because there is no vertical shift, it's going to start on the x-axis or when y = 0. Because if it's a vertical shift, that means that it's either going to go up on the y-axis or down on the y-axis. Because there's no shift, it's going to stick at y = 0. That means that, let's go calculate our period here. So period is going to be our b value. Notice how our b value here is always a number in front of x. So the number in front of x is just 1. So b is 1. So my period here is going to be 2 pi over 1, which is 2 pi. So that means that the length of a full cycle here is still from 0 to 2 pi. The entire length is still 2 pi. But we need to make sure, do we actually start at 0? And notice how this phase shift here, there is a phase shift. It's minus pi over 4. So that tells me that this means that this is going, minus sign means it's going right. Pi over 4. So I'm going to go pi over 4 to the right. So first, since we know that the midline is at 0 and my amplitude here is 1, that means the maximum here is going to be at +1 and the lowest is going to be at -1. So amplitude helps us helps us scale our y-axis. Now let's try to scale our x-axis. So notice that the phase shift here, everything on the x-axis is being shifted pi over 4. So what I like to do is basically plot or mark pi over 4 on my graph. And since it's to the right, I'm going on the right side of my x-axis, or the positive side of my x-axis. So that means I have to start instead of at 0, I'm going to be at pi over 4. Now from there, I need to draw one full cycle of a sine graph. But I know that the period here, or the wavelength, is going to be 2 pi. So what I have to ask myself is, if I add on 2 pi, where is this going to be at? So what is pi over 4 added with 2 pi? Let's do the math. So 2 pi is not written as a fraction, so I can, make that into a fraction, right? So this could be pi over 4 added with 2 pi over 1. You can always make a fraction by putting it over 1, a whole number into a fraction by putting it over 1. And then I need common denominator. So I'm going to multiply this 2 pi over 1 by 4, so the denominator can be a 4. And so now this is pi over 4 added with 8 pi over 4. And so if I add that, that's going to be 9 pi over 4 because that pi in front is just like a 1 pi. So added with 8 pi, that's 9 pi. And so that means that if I were to add 2 pi onto here, that would give me 9 pi over 4. But another important marker that I need to make is the halfway point. Notice how 0 to 2 pi, the halfway point is pi. I have a halfway point here for just the original sine graph. So I want to create a halfway point for this graph. So let's just think about it. If you have pi over 4 here, and this is 9 pi over 4, isn't the halfway point 5 pi over 4? Let's just count for a moment. So if this would be 2 pi over 4, then it would be 3 pi over 4, and then 4 pi over 4. Then it would be 6 pi over 4, 7 pi over 4, and then 8 pi over 4, right? And so notice that the middle here would be 5 pi over 4. So basically I'm just doing is like slicing these into pieces to get my middle point. Now I'm just going to erase all those markers. You can keep them there, but it looks kind of crunched. I'm going to erase them. But that's how I can figure out the middle number. It's just like, what's the halfway point? So if this was like 1 over 4 and that's 9 over 4, the halfway point is 5 over 4. And so from here, I can draw this sine graph. And so at pi over 4, it is going to be at 0. Because notice at 0, or when sine starts, it starts at 0. Then when it's between pi over 4 and 5 pi over 4, notice 0 between pi, it hits it at 1. So I know I have to hit it at 1. And then back at pi over 4, which is basically resembles to pi, correlates to pi, it goes back to 0 when y equals 0. Then when the halfway point between 5 pi and 9 pi, it's going to be the minimum at negative, and then back to 0. And so when I draw this curve, it's going to look very similar to that sine curve above. But the difference is that this has been shifted pi over 4. So that's why this curve here looks still the same, but it's just been shifted because of the equation that we were given. All right, that was a lot of ingredients here to keep in mind. So like I said, figure out these 4 components: amplitude, period, midline, phase shift. Amplitude will help you scale the y-axis. Period will help you figure out the wavelength of how long you have to draw your cycle. Midline will tell you where do you start on the y-axis. Phase shift will tell you where do you start on the x-axis. Okay, now that we've gotten a feel of this, let's practice more of this graphing. Okay, so here we have a cosine graph this time. So I'm going to quickly sketch what a cosine graph looks like. So cosine graph, you guys mentioned this before when we first graphed it. So it's still 0 to 2 pi for the original cosine graph. And the halfway point is pi. And so cosine starts at 1 when it's at x equals 0. And then when it's at pi, it's at the minimum. And then when it's at 2 pi, it's back to 1. Also notice that basically whether it's a cosine graph or a sine graph, where it starts on the y value is where it will end. It will end at the same y value. Notice how both of these end at 1 for the y values. And so when you draw this curve here, it looks kind of like a U-shaped curve. So cosine kind of looks like a U. And so this amplitude here for this cosine is also a 1. The period here, because, the x in front of the coefficient in front of x is just 1, this period, if we plug in 1, is still going to be 2 pi. There is no midline shift, there's no vertical shift here, so the midline is going to be at 0, y equals 0. And it's always, when you write the midline, you always have to write it with y equals 0, because it's saying like what y value is it at, what y value has it been shifted. The phase shift here, it looks like it's pi over 4, but this is a positive sign. So remember, positive means left. So this is going to be pi over 4 left. Okay, now that we have all the ingredients here, let's try to draw ourselves a cosine graph. So first I can start with the midline here. So the midline is at y equals 0. So that means I'm going to be drawing on this x-axis here. So there's no vertical shift. The amplitude tells us the height of the curve. So the max is going to be at 1. The min is going to be at -1. So amplitude is 1 up, 1 down. And then I have to figure out if there's a phase shift. It looks like the phase shift here is at pi over 4, but it's left. So that's going to be in the negative x values. And so instead of starting at 0, I'm going to be starting at pi over 4 negative. And then remember that your period, you need to add on to your phase shift. So if I were to add on negative pi over 4, add on 2 pi, this would be a negative pi this time, added on with 2 pi over 1. I'm just doing that same calculation where I change the 2 pi to a fraction. I multiply the top and bottom by 4 to make them common denominators. And so this would be negative pi over 4 added with 8 pi over 4, which would give me, well, since that's a -1 added with a positive 8, that's 7 pi over 4. So when I get to my full cycle, this would be 7 pi over 4. But let's figure out the halfway point, right? So if we think about this from like negative pi over 4 to 7 pi over 4, the next one would be at 0. So that'd be 0. And then this would be at, so I need to figure out the halfway point. So if this is 0, maybe this would be at 3 pi over 7. So let's see how many units is that away. So that would be 1, and then that would be 3. So that'd be like about 4 pi over 7, so about 4 units over. And then 3 pi to 7 pi is about 4 units over. Oh, sorry, that should be a 4. So I think this works. That's about the halfway point. By the way, if you're struggling with this, all you got to do is you can like just take 7 pi over 4 and half it and then just add it on to your phase shift. That also works. I just find sometimes like my number senses just make it a little bit easier. I can just figure out where the middle part is by just thinking about the fractions. So from here, I need to draw my graph. So at negative pi over 4, notice cosine originally hits the maximum when it's at 0. So I need to hit my maximum, which is also at 1. But then at the halfway point, I have to hit my minimum. So the halfway point is 3 pi over 4. And notice how at pi, it's hitting the minimum at -1. And then when I get to 7 pi over 4, which is the full cycle, I need to go back to 1. And so when I draw my curve, it's going to make this U shape. And so there we go. Here's my cosine graph for number 4. All right, now that we've gotten some practice with graphing, let's go back to just finding amplitude, period, vertical shift, and phase shift. We're going to pause here on the graphing just because we'll save that for next time. And please look at the notes that are continued because I just do more practice problems over graphing. And so that way you guys can get a better idea of how we graph. Okay, so here I have some more functions that we're going to find the amplitude, period, midline, and phase shift. So our amplitude here looks like it's, oops, sorry, that's not what I want to do. Amplitude here looks like it is a half. Absolute value of a half is still 1/2. Period here, it looks like our b here is 2. So if I were to calculate the period, be 2 pi over 2, which we calculated before, which is pi. So my period here is pi. That means the full cycle is completed within a pi length. There does seem to be a vertical shift here. So the vertical shift is saying that it is going down 1. So that means that this is y equals -1. So instead of being at y equals 0, it's going down, so it's going to be -1. The phase shift, let's look at our parentheses here. So this is 2x minus 3 pi. So I have to, because this is my b here, or the coefficient in front of x, I have to factor that out. So if I bring out this 2, I'm dividing. So this would be 3 pi over 2. And so it looks like my phase shift is right 3 pi over 2. So this is 3 pi over 2 right. Remember, phase shift, you have to tell me the direction. The next one here, I have also a half a pi. So my sorry, not a half pi, it's just a half for the amplitude. So there's my A. My B value here is a half. So my period, if I were to calculate that, that would be 2 pi over 1/2. So we're dividing by a fraction. So let's just keep in mind, when we divide fractions, we flip the bottom fraction because we multiply by the reciprocal. So that would be 2 over 1. If we multiply straight across, this would be 4 pi over 1, which is 4 pi. So my period here is 4 pi, which means that if I were to complete a full cycle, it would have a length of 4 pi. The midline here doesn't look like there is a vertical shift, so this would still be at y equals 0. The phase shift, let's take a look. We have 1/2 x plus pi. So if I factor out a half, I have to divide this pi by 1/2. And that's kind of tricky. So first, when you're dividing by a fraction, right, you have to multiply by the reciprocal. So if I multiply by the reciprocal, that's 2 over 1. So this is really pi times 2, which is 2 pi over 1, which is 2 pi. So that means that this here is really 2 pi, and this plus sign means left. So this is 2 pi left. So remember, factoring out numbers is basically division. You're going to take that number and divide it and figure out what is the real phase shift value. Let's do one more. Okay, so this one's a tough one. So first, let's figure out the amplitude. The amplitude here looks like a -1, right? But the amplitude is the absolute value, so that would be a +1 because amplitude talks about the height. So in this case, there's a height of 1. Our midline here looks like we have a vertical shift, right? Vertical shift up 2, so this is going to be y equals 2. So it's not going to start at y equals 0, it's going to go up 2, making it y equals 2. The period here, the b value is 3, so period would be 2 pi over 3, and I can't reduce that fraction, so it looks like my period is 2 pi over 3, which is fine. And then this parentheses here, so let me write it down so I can factor out my b, which is 3. So if I factor out a 3, that means I'm taking pi over 5 and dividing it by 3, right? So let's do that to the side. So pi over 5 divided by 3 is like saying pi over 5 multiplied by the reciprocal of 3 over 1, which is 1 over 3. If I work this out, that's going to be pi times 1 is pi, over 5 times 3, which is 15. So this is really 3x minus pi over 15. And so in this case, this is right pi over 15 right for my phase shift. And that's it. So check out the next notes to see some examples for graphing more complicated trig functions where you're going to see all these types of shifts.